It is not normal to have 30 volts alternating current at a light switch ceiling box when the switch is in the off position. This voltage reading indicates a loose connection or another electrical issue. Possible causes include a loose neutral connection, a loose hot wire connection, or induced voltage. A loose neutral connection can cause voltage leakage from other circuits into the light circuit when the switch is off. A loose hot wire connection can create a small current flow when the switch is off, resulting in voltage at the ceiling box. In some cases, voltage from nearby electrical wires can induce a small amount of voltage in the light circuit when the switch is off. Here are some troubleshooting steps to consider. Firstly, turn off the breaker. Always work with the power off when dealing with electrical issues. Secondly, check all connections. Inspect all connections at the ceiling box and light switch. Ensure they are tight and secure. Thirdly, test again. With the breaker still off, reconnect the wires and turn on the switch. Measure the voltage from hot to neutral again. There should be no voltage present when the switch is off. Fourthly, call a qualified electrician. If you still detect voltage when the switch is off, or if you are uncomfortable performing electrical work, contact a qualified electrician for assistance. It is important to note that 30 volts alternating current can be dangerous and should be addressed promptly. Never work on electrical systems unless you have the proper training and experience. The presence of 30 volts alternating current when the switch is off suggests that there is an unintended path for current to flow. This can be due to a compromised neutral connection, where the return path for the current is not properly established. As a result, the voltage seeks an alternative route, potentially through other circuits or even through a person who comes into contact with the wiring. A loose hot wire connection can also cause this issue by creating a situation where a small amount of current is constantly leaking even when the switch is in the off position. This leakage is enough to register a voltage reading even though the circuit is not actively in use. Induced voltage is a phenomenon where electromagnetic fields from nearby energized wires can induce a voltage in a nearby unenergized wire. This is more likely to occur when the wires are running parallel to each other for an extended distance. The induced voltage is usually small, but in certain circumstances, it can be significant enough to register on a voltmeter. To effectively troubleshoot this issue, begin by turning off the circuit breaker that supplies power to the light switch. This is a critical safety precaution to prevent electric shock. Once the power is off, carefully inspect all the wire connections at the ceiling box and at the light switch itself. Look for any signs of loose wires, corroded connections, or damaged insulation. Use a screwdriver to tighten any loose connections, ensuring that the wires are securely fastened to the terminals. After checking the connections, use a multimeter to test for continuity between the neutral wire and the ground wire. A good connection should have a very low resistance, close to 0 ohms. If the resistance is high, it indicates a problem with the neutral connection. Once you have verified the integrity of the connections, you can proceed to test the voltage again. Turn the circuit breaker back on and use a voltmeter to measure the voltage between the hot wire and the neutral wire with the switch in the off position. If the voltage is still present, it is likely due to induced voltage or a more complex wiring problem. If you suspect induced voltage, try rerouting the wires to minimize their proximity to other energized wires. If the problem persists, it is best to consult with a qualified electrician who has the expertise and equipment to diagnose and repair the issue safely. Remember, working with electricity can be dangerous, and it is always better to err on the side of caution. If you are not comfortable performing electrical work, or if you are unsure about any aspect of the troubleshooting process, seek professional assistance. The electrician will have all the necessary tools and diagnostic equipment such as a multimeter, wire tracer, and insulation resistance tester to determine the root cause of the problem. These specialized tools can detect hidden wiring faults, insulation breakdown, and other issues that may not be readily apparent during a visual inspection. The electrician may also perform a voltage drop test to assess the integrity of the wiring. A voltage drop test involves measuring the voltage at different points in the circuit under load to identify any areas where the voltage is significantly lower than expected. This can indicate a loose connection, a corroded wire, or an undersized conductor. Additionally, the electrician can assess the overall condition of the electrical system, including the circuit breaker panel, wiring, and other components to ensure that it meets safety standards and is functioning properly. They can also advise you on any necessary upgrades or repairs to improve the safety and efficiency of your electrical system. The presence of 30 volts alternating current on a circuit that is supposed to be off can pose several risks. Firstly, it can create a fire hazard. Even a small amount of current can generate heat, especially if there is a loose connection or damaged insulation. Over time, this heat can ignite nearby combustible materials, leading to a fire. Secondly, it can cause electric shock. Although 30 volts alternating current may not be lethal, it can still cause a painful shock, especially if you are in contact with a grounded object. The shock can also startle you, leading to a fall or other accident. Thirdly, it can damage electrical equipment. The unintended voltage can interfere with the operation of sensitive electronic devices, causing them to malfunction or fail prematurely. Therefore, it is essential to address the issue promptly to prevent these potential hazards. To avoid electrical problems in the future, it is important to follow a few simple precautions. Firstly, always use the correct size and type of wire for each circuit. Undersized wires can overheat and cause a fire. Secondly, ensure that all electrical connections are tight and secure. Loose connections can create resistance, leading to heat and voltage drop. Thirdly, protect wires from physical damage. Avoid running wires in areas where they can be easily pinched, cut, or abraded. Fourthly, regularly inspect your electrical system for any signs of damage or wear. Look for cracked insulation, loose connections, or corroded terminals. Fifthly, never overload circuits. Overloading a circuit can cause the breaker to trip, but it can also damage the wiring and create a fire hazard. If you are unsure about any aspect of electrical safety, consult with a qualified electrician. They can provide you with expert advice and guidance to ensure that your electrical system is safe and reliable. When working on electrical systems, it is essential to use the proper safety equipment. This includes insulated gloves, safety glasses, and a voltage tester. Insulated gloves protect you from electric shock, while safety glasses protect your eyes from flying debris. A voltage tester allows you to verify that the power is off before you start working on the wiring. Additionally, it is important to work in a well-lit area to avoid mistakes. If you are working in a dark or dimly lit space, use a flashlight or work light to illuminate the area. Before starting any electrical work, it is always a good idea to consult with the National Electrical Code (NEC) or other applicable electrical codes. These codes provide detailed guidelines and requirements for electrical installations, ensuring that they are safe and compliant with industry standard. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. By following the NEC, you can minimize the risk of electrical hazards and ensure that your electrical system is safe and reliable. It is also important to stay up to date on the latest changes to the NEC. The code is revised every 3 years to reflect advancements in technology and changes in industry practices. By keeping abreast of these changes, you can ensure that your electrical work is in compliance with the most current safety standards. When working with electrical panels, it is essential to exercise caution. Electrical panels contain high voltage components that can be extremely dangerous. Never open an electrical panel unless you are qualified to do so. If you need to access the inside of an electrical panel, be sure to turn off the main breaker first. This would energize the entire panel, reducing the risk of electric shock. However, even with the main breaker off, there may still be some residual voltage present. Therefore, it is important to use a voltage tester to verify that the panel is completely de-energized before you start working on it. When working on electrical projects, it is also important to obtain the necessary permits. Many jurisdictions require permits for electrical work to ensure that it is performed safely and in compliance with local codes. The permit process typically involves submitting plans and specifications to the local building department for review. Once the plans are approved, you can obtain a permit and begin the work. After the work is completed, It will be inspected by a building inspector to ensure that it meets all applicable codes and regulations. In summary, finding 30 volts alternating current at a light switch when it is off is not normal and indicates a potential electrical issue. Begin by safely disconnecting the power at the breaker. Carefully inspect all wiring connections for looseness or damage. Use a multimeter to test for continuity and voltage. If the problem persists or you are uncomfortable with electrical work, consult a qualified electrician. Remember to prioritize safety and follow all applicable electrical codes and regulations.